Good morning, everybody. Welcome to our 12th workshop about the Colombia round 2021. We are now in our second cycle of conference, and this week we have the pleasure to present to you the members of the UPTC University, and they are going to give us the talk of Caguan, Eastern Cordillera Caguan. And I would like to remind all of you what are the topics for the following weeks. We will have next week a Catatumbo on July 9th. We have invited Dr. Ivan Olaya, and we will have our ANH interpreter, Daniel Rodriguez, with us. On July 16, we will have Guajira onshore and Guajira offshore, and we will have Dr. Juan Carlos Ramon with us. On July 23rd, Putumayo, we will have also Dr. Ivan Olaya and our interpreter, Arles Gutierrez. On July 30th, we will have Cesar Rancheria Basin with the ANH interpreter, Arles Gutierrez. And we will close our second cycle on August 6th with the talk Conventional and Unconventional Resources in Colombia Yet to Find, and is going to be given by Cesar Mora, Dr. Cesar Mora. What is new? What is new today? I mean, well, we have a good news for the round. We have the good news that we have another incorporated area for us for the round. So in total, we have 5 incorporation of companies in open areas. So we have 2 in the Llanos, 2 in the Middle MAC, and 1 in the Lower MAC. So those 5 plus or 28 proposed areas by the agency, we have a total of 33 areas so far in this round. So we encourage all the companies to incorporate areas and make this effort great for the country. So just to remind you that we will be waiting for all of you. Next week we'll have the Catatumbo mega area. From 8 to 9 we will have the talk titled Hydrocarbon Prospectivity in the Catatumbo Basin by Ivan Olaya. And from 9 to 10 we will have the hydrocarbon opportunities found by the ANH in the Catatumbo Basin, and is going to be given by Daniel Rodriguez, one of our interpreters. I know that there are a lot of students today with us. I hope, I don't know, but I hope that there are a lot of students. Don't forget that we are interested in supporting theses, or we are in the process to get the approval for doing that for people, for the students in the last years, or maybe for people that will start the postgraduate studies in the country. So we're in that process, and we will make the announcements. I mean, so the purpose of this comment is to encourage all the students to follow our talks, because they are related to the frontier areas, and the agency is interested in promoting the frontier areas. So don't miss any of our talks, and we will give you some news in the coming weeks in regard to those opportunities for thesis in those areas. Okay, so today we have the pleasure, we have the Eastern Cordillera Caguan mega area. We will have two talks. The one in the Eastern Cordillera Basin is titled Geological Integration, Evaluation of Oil Systems and Prospectivity. And we have the second talk, Caguan Sub-Basin, Geological Integration, Evaluation of Oil Systems and Prospectivity. And we have very interesting people here from outside the country. I mean, they are joining us from Alemania, Germany, from England. Wow, we have very interesting people. We have Dr. Luis Vergara with us. Luis has a degree in geology from the National University of Colombia, sede Medellin, and he has also his doctorate degree from the University of Gießen in Germany. He worked in Geominas and the National University in Bogota before joining the oil industry. He then worked 3 years for Deminex in Colombia, 12 years for RWE DIA, with assignments in Germany, Norway, Poland, and Egypt. And also, Luis worked 9 years for Apache Corporation in Egypt, where he spent, Since then, he's now an independent consultant based in Germany. So we welcome Luis with us. We have a little confusion if he spent 9 years in Apache or 13, but Luis maybe clarify later. Okay, Andres Mesa is also one of our speakers. Andres Mesa is a consultant geoscientist with over 16 years of experience in the oil industry and gas, oil and gas industry. He has a bachelor in geology from the National University of Colombia and a master's science in petroleum sciences from the Royal Holloway University in London. He worked 9 years for HOCOL, for the exploration team in Colombia, and became an independent consultant in 2014. He has experience in the exploratory assessment of basins or at block scale. Part of the evaluation that he has done during the M&M processes and bid rounds evaluation. He has experience also in bid round evaluation. He's currently based in London, so we welcome Andres this time for our workshop. We have also the pleasure to have Kurt Bayer. Kurt has a degree in geology from the National University of Colombia, Bogota, and a master in technology management from the Universidad Pontificia Bolivariana in Bucaramanga, Colombia. He worked 1 year for Texaco and 12 years for Ecopetrol, and also 12 years for the Instituto Colombiano del Petróleo in Bucaramanga, Colombia. Since 2000, he's an independent consultant based in Colombia. He's an emirate member of the APG, and he got the Wheeler Award from the Asociación Colombiana de Geólogos y Geofísicos del Petróleo. We have also the pleasure to have our professor, director from the UPTC University, Professor Carlos Julio Rodriguez with us. And we would like to thank him for all the effort that the university has done to support the ANH on all these exploration efforts. Okay, I would like to give just the talk to the first speaker, and then don't forget, you can address all your questions to the chat, and you will get the answer to the chat. But at the end of the talk, Daniel Rodriguez, who is going to be closing the conference, he will read all those question answers at the end, just to close up the conference. Thank you very much, and welcome to this workshop.
Miguel, maybe you are going to introduce Cesar Mora.
Oh, sorry. Oh my God, I forgot to introduce the most important speaker this morning. I'm sorry. I have Cesar here in a different paper. Cesar, sorry, I apologize. Cesar Mora is a geologist with more than 33 years of experience in basin analysis and prospect evaluations, plate concept assessments, petroleum system modeling, petroleum geochemistry, and yet to find assessments. He has been involved in regional studies in Colombia, Ecuador, Peru, Chile, Mexico. He has worked for companies such as Ecopetrol, Cipetrol, HEMS, and Cuenca. He is also professor of petroleum geochemistry and basin modeling in several universities in Colombia. I'm sorry, Cesar. Okay, Kurt, thank you very much. Okay, go ahead.
Okay. Good morning, everybody. Yeah, I'm going to share my screen. And, okay. Okay. Good morning, and thanks, Miguel, for the introduction, and to the ANH for the opportunity to present the results of the study that we did with the Universidad Pedagógica y Tecnológica de Colombia. As Miguel said, we're going to present the first basin, the Eastern Cordillera Basin, and its prospectivity. And the presentation will have the following content. I will present the work team. After that, Luis Vergara will present the regional geological framework, the petrophysics. And after that, Andres Mesa will present the structural section, and Cesar Mora, the petroleum. Oh, I see. Okay. I apologize for the microphone. I know that was off. Okay. Let me. Okay. Thank you very much. Okay, I'm going to go back a little bit. Okay. Thanks, Miguel, for the introduction and for present all our speakers. And thank you to the ANH for the opportunity to present the Universidad Pedagógica y Tecnológica de Colombia study. Okay, the first basin will be the Eastern Cordillera Basin. And well, as Miguel said, we are going to present the geological integration, the relation of oil and prospectivity of the basin. Well, the presentation, we have the following organization. We are going to present the work team. After that, Luis Vergara will present the regional geological framework and petrophysics. Andres Mesa will present the structural sections, plays and prospects and leads. And Cesar Mora, the petroleum system identifying. And at the end, I will present the final comments of the project. Okay. The work team was organized, was made up of 14 professionals. It's a multidisciplinary group. And I want to thank all of them for their compromise and for the great work that they did in this project. Thank you very much to all of them. And now I introduce Luis Vergara, and he's going to talk with you the geological framework and stratigraphic sections. Okay, Luis, the floor is yours.
Right. I was looking. Well, thank you very much. My name is Luis Vergara. Are you seeing my screen? I hope so.
Yes.
Good. So the topics I'm going to talk about today are the geological framework, the Chronos stratigraphic sections, and the gross depositional environment. So first, to introduce the area, which is the Eastern Cordillera of Colombia, which everybody knows, especially the oil industry, which happens to sit in the very middle of it here in Bogota. So this is a simplified map with the main structural elements put together by Kammer and others last year. So the basic elements I need to stress today are the well, the East Virgin Guaycarmo Fault System, which is the border of the basin towards the east, towards the Llanos Basin. And the basin is also limited by the La Salina Fault System at the west, which is West Virgin. and includes also the Tuima Fault, the Cambao Fault for the south. And in the area of the Hiradod, you have the Prado Magdalena Fault, and further south is the Varaya Fault. This is the limits of the basin in the west. In the east, we have a very narrow fringe between the Guaycaramo Fault system and the major thrust, the front thrust, which is the Yopal Fault. And that area is very prolific and it's very well known. It's the Llanos foothills, where there is lots of production and major fields. This is not the topic of today's talk, but there are a couple of wells in that domain that we're going to mention. We have the Garzon Massif and the Ketame Massif as the blocks where the crystalline rocks and polyzoic rocks are exposed. Then we have for the north, the Floresta and the Santander Massif, which is also non-prospective with crystalline rocks and Jurassic. The basin is basically divided in several sub-basins, the most important of which is the Bogota sub-basin, which is at the axis and the axial zone, where the basin attains the highest thicknesses and so an area of very high subsidence. Then we have the Kokuisu Basin, which is the same Merida sub-basin towards a little bit towards the south. Over here in the eastern flank of the Cordillera, in the western flank, we have the Tablazo sub-basin, grades towards the Tequendama and Villeta areas. Here there's very intriguing alignments of possible transfer zones that have been proposed. And I'm going to talk about a little bit about them in a while. And then in the southern, southwestern part is basically everything upper Cretaceous. And you see the tertiaries exposed basically or preserved basically on top of the synclines. To the stratigraphy, this is a very nice diagram put together by Mauricio Parra and others. Basically, the phases on the basin evolution are well accepted to start with a rift area and a syn rift domain bordered by the two faults that the Guaycaramo fault here and the La Salina fault systems, which were normal faults at the time. And then you have this accumulation of deep water early Cretaceous rocks that are non-prospective. That's the syn rift zone. They have based most of the things by thermochronology. And you can see here the areas that I mentioned earlier, how the stratigraphy varies. At some point in the Albian and so, then we have thermal cooling and the post-rift phase, and the basin evolves into a passive margin where very important reservoirs coming from the west, from the east, from the Guyana Shield are laid down, particularly the Une and Guadalupe formations. We're going to detail a little bit in a bit. And the source rock obviously appears of major transgression where the basin spilled over the Llanos, and especially at the end of the Turonian, very well known anoxic events that deposited the Chipake Formation and equivalents, which are the main source rock of the area. There's also Fomek is also a source rock. Cesar Mora will talk about those things later. We have here the elements of the petroleum system with seals. And then at some point in the Paleogene, the basin then, the faults and major faults inverted, the basin inverted, became a four-land continental basin. And we have basically continental reservoirs that are productive in the area, like the Socha Cacho, and especially the Mirador Formation in the Medina Basin and Llanos Basin, but also in the central core, its equivalents are prolific, and they are topped by shales known as Carbonera, Concentración Usme, and so on. So the basin, as was delivered to us, this is the basin outline, which is overdue to be redefined because in the light of the new maps published by the Geological Survey, well, this is very rough definition, but the new maps have given a lot of detail on how the faults can be traced, and that's overdue to be redefined. But we worked on this study area. We had some wells available that are depicted here. The basin is actually said to be a frontier basin, but that's mostly because of its underexplored character than by the fact that it has production that makes it actually, per definition, a proven basin. And it's proven in Gibraltar up there. A discovery, very nice discovery in the Mirador by Ecopetrol. And there's a paper there published by Villamil and others in 2004, all of the details, very comprehensive about that field in particular. Then we have in the area of Sogamoso, we have the Bolivar and Corrales, where the Guadalupe, upper Guadalupe is producing. So that's a proven play. Also the Guando field. Actually, it was a pity we didn't have any access to the wells of the Guando. That was not available for us, but we'll talk about it based on publications. That's in the Boquerón area, and that's also a Guadalupe play, particularly the Arenisca Dura is prolific there. And also at the very limit with the upper mag, we have the Venganza field. Arguably belongs to the neighbor basin, but in the agency's definition, it is part of this. It's going to be part of this study. So we have access to that well. So we're going to show a little bit of that. Forgot the axial sections. This is the chronostratigraphic sections, and they look a little bit funny because they are tying all of the wells. Just a second, we used 30 wells that had biostratigraphic and paleo-environmental information, preferably deep levels that penetrated deep levels. We have one axial and 3 cross sections. So I'm going to start with the axial section that goes from the very far south, which is the Güenge well, up to the very far north, which is the Gibraltar discovery. And then we'll talk about the others. So this is the axial section. They're very rare in the literature. I only know of a couple of them in Luis Sarmiento's thesis, but very little published in this dimension. It starts in the very south, in the southwestern. There is an area of little subsidence, and most of it is upper Cretaceous. Lower Cretaceous is there represented by the Javi and Cavaliers formations, filling a terrain. And once you get across the Nazareth Paleo Fold, which is a term coined by Luis Sarmiento and others in subsequent publications from his thesis, then you got the area of very high subsidence, which is known as the Bogota or Cundinamarca subbasin. I'm not sure which is the right name for it, but certainly Bogota subbasin is easier for the foreigner investors. So we'll keep it at Bogota Basin for the moment. You have the areas going into the Cocuy, where the lower Cretaceous is incised and exposed. We have the salt deposits interbedded in the Macanaz shales, which have been dated hot Rivian, Valanginian is the dating basin polynomals there in the Zipaquirá area. Then we have one of the major targets, which is the Une Formation, targeted in several wells here. The upper Cretaceous with our source rocks, and then the Guadalupe typically with the 3 formations, very little preserved on the Maastrichtian Paleocene, known as Guadalupe Seca. Here in the area of Sogamoso, Paz del Rio is where we have a good preservation of the Paleogene section, which is again prolific in Corrales and Bolivar. Towards the south, we have these molassic deposits proper of the Girodot area and the Fusagasugá shales. And here the Gibraltar, which is now the nomenclature and stratigraphy proper of the Llanos foothills with these penetrations. These are the well control. The uplift episodes are compiled from Mora and others, 2019. I think the next section shows that better. This is in the Sogamoso area, crisscrossing from Tablazo to the Kokuisu Basin. And here from west to east, we have La Salina at that point in time, still a normal fault before it reactivated at some point in the Albion. And there are a couple of wells here drilled by Nexen for unconventionals that had control here in the lowermost Cretaceous shales. When we come to the Sogamoso area, we have the Floresta Massif inverted in the Eocene. by the Swapagap and Boyaca Paleofolds, and then we have the lower Cretaceous, then unconformably overlaying Jurassic and Paleozoic rocks there. Very nice exposures close to Vitama and that area. At the east, we have the basal conglomerates of the Buena Vista, which are known from the Villavicencio area, and other deep water units that have undergone so much boreal that are pretty tight. Then we have the Une Formation again in the post-drift, which is equivalent to the Churubita, at least in the upper part, which is Cenomanian. I'm interested, this well was pretty interesting, but sure, well, remember this is the time domain, so the thicknesses might be a little bit misleading, but this well penetrated actually 1,000 feet of massive sandstones assigned to the Chipaque Formation. It's very interesting, possibly secondary targets in the future. Then we have, well, here in the Floresta Massif, the lower Cretaceous is exposed. And then again, very little Paleogene deposited or preserved there. Much more here in the Cincinal del Desespero, which is down there. And the Huron well at the very Guaycaramo fault system at the tip of it, but the penetrated section very similar to the other Gibraltar well that I showed earlier. Interesting here, well, the uplift history and exhumation history of the Cordillera has been put together by the team of the ICP led by Andres Mora, and this is one of the latest publications. And in essence, the uplift started in the Paleocene, in the mid-mag, and kind of migrates, it's diachronic, it migrates towards the west and becomes progressively younger towards the west. Here is Oligocene, here is uplift in late Paleocene, here is in the Eocene up to now. Here also late Oligocene up to now in Ketame, and finally in the eastern Llanos is from the middle Miocene up to now. So a progressive orogeny towards the east. So this section now is at the very core of the Cordillera, so we call it Carupa. Again, we have then wells for unconventionals that penetrated or had control over the Murca sandstone, which is exposed and known to be practically deep water turbidites coming from the west. Then the deep basin, which is undrilled and presumably very, very thick, dozens of kilometers up to that. Has been speculated. This we saw before. And then we have also in the Carupa well, which is another unconventional well drilled by Nexen. Very interesting also surprises that I got there, because I don't think this sandstone units that are interbedded in the Paja Formation and the Conejo, and even in the Frontera, which is the Soso, I don't think they are well documented in the surface. Same thing for the Nemqueteva well. There's a sandstone, very important sandstone in the middle of the Fomeque Formation, another one, the Chipaque Formation. That was surprising to me when I saw these wells, because I'm not aware that they are known from the surface, documented well, and those are obviously potential reservoirs. The Une now interfingers with the Chiquinquirá Formation, which is basically the same Churubita. But then for the south, it's called Chiquinquirá, and it's very calcareous, mixed rocks. Chipaque, Conejo, the Guadalupe well behaved there with its 3 units, 3 formations that everybody knows from the area of Bogota, and Siechas syncline, also in the area of Bogota, where there is a well-preserved section of the Paleogene. Right, so what else can we say about this? Let me move on to the next Apicalá. Apicalá section in the south. Here, note that the scale is different, and we don't have much wells. They're all wells from Ecopetrol from the 80s, Suarez, Apicalá, and here the Javí Formation was already described under another name in those wells, but is known to fill all this relief, or paleo relief of grabens and horsts that formed at the time. And then the Cavaliers Formation also 3 units in grades at some point. It's called the Une Formation up in the Paramo de Sumapaz, lying above Fomeque, and very conspicuous basal conglomerates of the Cretaceous. across the Nazareth Paleofold. Then we have in the Upper Cretaceous now the Olini with the Olini group with the typical upper and lower church, and there is a very interesting sandstone sandwich in between both, known as El Cobre sandstone. I think that's also a secondary target in some parts in the Magdalena Valley. Busca Vida Formation. This is a nomenclature of the Girardot area, and upgraded by Guerrero and others some years ago. And then the syncline and this well, then the molasses from the west are penetrated. And again, in this synclines, this is the Prado syncline. This is the another syncline over there, the Fusagasugá syncline most likely, and this is the Colombia syncline, also known as well, the Geological Survey calls it San Bernardo syncline. I think there are synonyms. And another one unknown is where you have the the tertiary well preserved and exposed. So let's go to the gross depositional environments, or GDEs. And in this one of the Albion Cenomanian is actually very gross, because there's a very long time represented here. But the goal was to just to capture the main reservoirs and see how they map out where just to support the play fairway analysis. And then you have to map grossly the extension of the sands of the reservoirs. In this particular case, the reservoirs are the UNE, or the equivalents are called Aguardiente, Churubita, Chiquinquirá, and Caballos. We're in the initial post-rift phase, which is marine. The basin is confined by this border synrift faults, which at this time might have had still some influence in the sedimentation. Is linear sourced from the east. The western provenance is uncertain and matter of speculation. Here, that's the depositional limit, or the zero edge line to the Guyana shield. We then study the Llanos, but that's where the Vaca Formation, very sandy, is interpreted as a delta plane. And this is based on a report by Cediel and others for the Geological Survey. We don't have access to that part. But then at some point, when it becomes marine east of the Guaycarmo Fault system, then we've got these wells here of control. We've got the type sections of the UNE here, and other exposures that document as channels, beach, shore face, sandbars, etc., little sands. And at some point, you go into the area of Villaleyva, where it becomes mixed rocks of the Churubita Formation, shallow marine. Then Chiquinquirá, also middle to inner shelf with storm beds published there, and more, more shales in Mijaca Formation, all attributed to the mid shelf. But in the area of Tequendama, Villeta, all this part going into the Girardot area, the equivalent in the Albion is very organic rich, chert rich. It's an area basically of the Hilo Formation of the outer shelf setting, and it goes into the Tetian limestone in the area of Girardot, and it grades into the Caballos farther south. This is the type section of the Caballos, and the type section of Churubita, type section of Chiquinquirá, and the type section of the UNE sitting right here. So these are my sources. Here you can see the sources of the environments here in the labels that can be checked up in the report. The next gross deposition environment is the early maastrichtian, companion early maastrichtian, which is basically the Guadalupe, Palmichal, La Tabla, or informally known as Monserrate, and also the Cimarrona Formation. We're now in the final post-rift phase, which is marine. The provenance is dual, not only linear sourced from the east delta plane, very similar to before, but more spilled over, and also from the ancestral central Cordillera. This also sourced from there, basically point sourced. The Cimarrona Formation is actually like an alluvial fan there with bioerms, and it's got production from the Onda field over there. But they're basically the same scheme of inner marginal marine, very broad coastal belt. Everybody knows the Guadalupe east of Bogota, the very good exposures there, very good studies, also wells. The They're described as tidal flats or shore face deposits, sometimes wave dominated, sometimes tidal dominated. And then it behaves pretty good. It shales out or becomes the planars formation in the area of Villaleyva. That means the upper Guadalupe and the lower Guadalupe in particular that are already here, not outcropping in the Tabia section. They become the planars formation, something that was already documented by Italia in 1968 in the area of Villaleyva. That's middle shelf, and if you go out further out, then you encounter faces proper of the outer shelf, in particular here the Chets and the Olini group, very cherty, typical outer shelf, very marine. And then the La Tabla formation where Venganza is sitting, then you have sands prograding from the west. Guando, again, unfortunately, we didn't have access to those wells. They were confidential for this study, but there are a couple of publications there with core descriptions, and they attributed to mid-lower shore phase. The people from Nixon interpreted as tidal inlet and valley fill. So different interpretations there for the arenisca dura, but all in all, they fit well this very big fringe of sandstone belts, inner marine, marginal marine, and inner marine. Finally, well, this is the last GDE for the early to mid Eocene, post the Eocene discordance, also known as the Eocene unconformity. This is now the foreland basin. A continental basin is confined by several exhumed interbasinal blocks with multiple area sources. It's got two main fairways. It's got two depocenters. The reservoirs are the Mirador, Picacho, the Galera, and Gualandai. This model is actually redrawn from Caballero, published last year, but they in turn modified it from the original model of Regis Harker in 2015. I just put everything together from basically from the same team led by Andres Mora from ICP that published these things in different publications. I put them together. The provenance axis, Alfred Mora and others, 2013, that go put the drainage towards the north, and then we have this Middle Magdalena axis and this Cordillera central axis. And they also put together the inverted folds at the time, which bring up, for example, the anticline of Rio Blanco, Villeta, Altagracia, Bogota, where it's also exposed. And Boyacá fault also brings up the Cordillera de los Cobardes area, and Floresta Massive becomes exposed. And then comes Herman Bayona and others, and then talks about concentrates on the synclines of Guatavita and Usme, and then calculates very high sedimentation rates there in excess of 150 million meters per million year. And also the other depocenter would be here in the San Juan del Rio Seco area, with alluvial fans point sourced from the west. I just try to put everything together, but there's nothing really new here. What else can we say about this model? Yeah, in Gibraltar and Huron also, they are, you know, the Mirador has a tendency to have some tidal influence, or become in parts a little bit marine, inner marine, especially in the upper Mirador. And here in Gibraltar, there you know, here my reference are core analysis that talk about estuarine deltaic environments, and it's even cold bearing. Same for the Huron, which is more or less in the same setting. All right, so let's move on to, okay, that's so far for the stratigraphy. Let's go to the petrophysics. This is work done by Helman Bonilla, our petrophysicist. I'm just going to read his work and start with the Nemketeva well, which was the main target in this well drilled by Morel and Crom. Yeah, you know, Une is at this point attains a thickness in excess of 1,300 feet. But of course, you know it from outcrops in the eastern part of the Cordillera, which it attains up to 1,400 meters, 1,400 meters, and for 1,200 feet or so in the surface. And it's very massive sandstone. And here in the well, this well, I forgot to show it in the maps, but this is exactly in the axis where it becomes where the Une starts to grade into the more mixed phases of of the Chiquinquirá formation, so the net to gross is not as high. In the mud log, you see massive sands here, but in wireland logs, you see quite amount of intra-formational shaly intervals here, but very clean zones nevertheless. And volume of shale is 50% average, down to 15% in these shaly sections. Phi E's in the order of 4 to 7%. That you can assume that it's a pretty tight reservoir, but the permeabilities that have been calculated are actually pretty good. And very important, this well-tested gas, just a stone throw away from Netqueteva and the Suezca 1 well drilled by Texaco in 1962 from Cenomanian sandstones attributable to the Une formation. They tested 7.2 million cubic feet in total, so more than a million day rate, more than 1 million scuffs per day. So that's an important target, and it's a hope for the exploration, for the future exploration in the basin, because it's still an unproven play, but again, it can hold gas, at least. Caballos, as opposed to the Une, Caballos is a well-established proven reservoir in the upper mag. Here in the southwestern Cordillera, it has been penetrated, as I showed before, but it's not, as far as I know, it's not yet productive. Typically, it has 3 members. The lower member is probably the most, the sandiest, and the upper member is not well developed. This is a well drilled by Hocol, as the thickness of the whole Caballos is more than 1,500 feet, porosities above, average of 10%, and the clean zones, like here you can see details of the wells, up to 25% porosity, so it shouldn't be tight. It shouldn't be tight. It should work also in the area. You have the permeability log here with up to 1,000 millidarcies permeable. So that again, still not working in the area, but the reservoir is adequate. The Guadalupe formation, in turn, that's a proven reservoir again in the Corrales Bolivar. Here's the complete section. This is wells drilled by Omega Energy that is developing the fields, thickness 300 feet roughly. Phi E's up to 30%, volume of shales less than 8%, and permeabilities around 1 darcy. So those are proven reservoirs, no problem. The Eocene reservoir also proven in the Gibraltar 3 wells, very blocky, massive sandstones of those alluvial fan deposits I showed earlier. Volume of shale is low, permeabilities around 800 millidarcies, porosities in the order of 25 to 30%, as opposed to the original Gibraltar 1 well drilled by Oxy, where they reported porosities of 6 to 11% maximum. This one has, according to Hellman's calculations, very good porosities. Picacho formation also in Corrales. This well is basically sandy, blocky. Net to grow is eyeballing it. It should be about 90%. This other well is less so, but these shale intervets are actually very convenient to trap the oil. Massive high net to grow sandstones, clean areas, volume of shale down to 10%. And it is oil bearing in Corrales. I'm not aware that it has been penetrated or producing. I wouldn't be surprised if it's producing. But as far as I know, at least it is oil bearing, oil saturated. So now we have this is my last slide, which is about the seals. Didn't have too much time to put work on the petrophysics of the seals, but even so, the Chipaque formation thickness is more than 4,200 feet thick. That should work very good, and it drapes the Une. And well, there are some stringers, but that should work very good for the Une play. Ondita works for the Caballos play demonstrably, and the Tetuan limestone sitting just below, also very thick. The Corrales, that's the Guaduas. That's a different type of seal, which is a proven seal because it seals off the Guadalupe in those fields in the Sogamoso area, especially the lower part of the Guaduas has up to 90% and more of shale. Then it becomes sandier. Walvas is known for the sand interbeds or sandstone formations that have reservoir quality, and also coal bearing, very colored mudstones. But it's a proven seal in that area. And finally, the Concentración, which is also the same, or the Carbonera formation in the Llanos for that matter. They seal the Picacho or the Mirador, and they're proven seals with up to well, 80 to 90% volume shale. So that's all I have for now. So I'm going to give the floor now to Andres Mesa.
Thank you very much, Luis. Okay, so I'm going to expose the structural sections and the exploratory place of the area. I want to thank the interpreters that are listed here who did an amazing job in such a short period of time. The actual Cordillera, it's a basin that was formed during the Jurassic and early Cretaceous times during a rifting phase, and was then deformed and uplifted in several stages, as Chris mentioned, during the Paleogene and Neogene. Based on the seismic data available in the area, it was subdivided in 3 sub-areas. To the north, close to the, or in the area of the Gibraltar field. Then in the center part, the actual and eastern foothills. And then to the south, in the limits to the upper, with the upper Magdalena Valley, 3 sections in the southwest. So we are going to start from south to north. We're going to start here in the southwest. So this is section number 1, and I'm going to highlight the main structural features and what do they represent and how do they evolve along the area. So in number 1, it's the Prado Fold systems, which put in contact the Jurassic sequence against the Miocene sequence of the upper Magdalena Valley. And number 2, it's the San Pedro anticline or the Alpujarra Fold system. And number 3 is the Colombia syncline, which is running in this direction. And to the east of that is the Ketame Massif. And what I want to highlight here is that between 1 and 3, the structural relief is much higher than what we can find to the west of this fold system. The early Cretaceous and Jurassic are shallower than what we can find here. Then moving to the north, this is section number 2. Again, number 1, it's the projection of the Prado Fold system, which is running northeast, southwest. And number 3, it's the projection or where the Colombia syncline is outcropping. And again, what is important here to notice is that all this area, it's much higher than what we can find to the west of this fold system. To the west, we have the Macarena Fault, and that is putting late Cretaceous against Miocene segments. Here we can see a very indicative sequence, the Miocene sequence, which is in an angular unconformity against the Paleocene, Cretaceous, and Jurassic sequence, which was deformed during the Eocene or early Pliocene deformation stage, as Luis mentioned before. Related to this deformation are the Venganza and Revancha wells, which produce from the late Cretaceous reservoirs, and they are related to structures that were deformed during this deformation stage and were fossilized. And then this is section number 3 to the north, in the limits of this area. And number 1, it's pointing the north extension of this Prado Fold system, which is no longer as big as was to the south. It's decreasing its deformation and its importance. And all of this area is plunging basically to the north, it's ending against this area, and we're going to see that in the next slide. And to the west of this area, again, we're going to see this particular setting where the Miocene sequence it's fossilizing, or is in an angular unconformity against the Paleocene and Cretaceous sequence, which was deformed during the Eocene event. Here, it is important to remark the Guando field, the Guando produced from late Cretaceous reservoir, and it is important because it proves the play, which is the subthrust against these thrusts. And this is important because most of the times the late Cretaceous reservoirs are outcropping or have been eroded. Therefore, to find this kind of play, which has been proven, and this field has produced more than 100 million barrels since its discovery, it means that this is an important play to be pursued in all the basin. And here we have a summary where, again, the takeaway message here is that between this #1 fault, which is what we are calling the Prado fault system, and this fault, which is limiting the Catania Massif from the Colombia syncline, this area has a structural relief which is higher than what we can find to the west of it. And here in this area, we can see that the deformation stage during the Eocene was, it can be seen, it is evident, while it is not in this part. Also, this deformation is plunging or is ending against an accommodation zone. We interpret that because from the north, when we see what is coming, the twin fold, which is the frontal fold that limits the eastern Cordillera from the middle Magdalena Basin, this fold, which is in this area, is running northwest. It's also ending again around this area, and the Villeta anticlinorum is as well ending or plunging against around this area. And as Luis mentioned, the Nazareth Paleofold, or how has been called before, from this point towards the north, we have the early Cretaceous sequence preserved and deposited and preserved, while in this area we have Aptian sediments on top of Jurassic sediments. So that section is not present here, while it is present here. So therefore, this is interpreted as an accommodation zone, which is typically formed during the rifting phase during the formation of any kind of these basins. This is the structural map of the Cavaliers reservoir, the Aptian Albion reservoir, and here is #1, which is the same fault system that we exposed before, and this is #3, which is a little bit outside of the seismic data. And as we can see, this area is higher than what we can find to the west, and the kind of plays or the kind of play that we can find associated with this reservoir are inversion faults that creates anticlines here, and more seismic is needed to map out properly one of these possible leads. And to the west of that, we have relicts of deformation that took place during the Eocene and that was fossilized by the unconformity. So we can find some of them here where the Cavaliers formation is preserved, and it's involved in those faults. This is the map of the top of Guadalupe, the one that produced in Guando. Here we have a section of that runs across Guando field, and here we can see the reservoir, which is sealed by this thrust. So this subthrust play is really important. Again, here we can see that all of this area, the reservoir is not present. So it's good to have this opportunity to have it in the subcrust of the faults, because along these areas we can target the same play. Several wells have been drilled in this area and in this area, some of them with little success, not as big as Guadalupe, but still this can be also pursued in other parts of the basin. Then we're going to move now to the center part, the actual basin, the actual part of the basin, and the foothills area. So this is section number 4. From west to east, we have first the southern extension of the Tablazo Basin. This was not one of the aims of the project because there was no seismic data, and also the conventional sequence of the petroleum system has been eroded. Therefore, this is not this was not part of the study. Then between number 1 and number 3, we have the Bogota sub-basin, where we think that the salt deformation is important, and it has created several structures that can be chased by the industry. It is a really important play. We're going to see some detail of it in a moment. From this point, which is the Machta fault system, to the frontal or the border of the eastern Cordillera, again, all this area, the petroleum systems of conventional petroleum has been eroded. Therefore, this was not part of our study. And then from this area to the Guadalupe or to the frontal deformation faults, we have the foothills area where there are plenty of structures, and most of them, they have target the Oligocene, Eocene reservoirs, but in recent times, the early Cretaceous reservoirs, they have been chased, not in foothills, but close to the foothills. Therefore, this is a play that should be explored in the area. Focusing a little bit more in the actual zone, as I said before, the area close to Bogota, there is an important play that should be looked in more detail. Several things that can be highlighted. There are salt mines. Therefore, the salt is there, and it has an implication in the deformation stages. In the few seismic that we have in the area, which are not of the best quality, we have symmetric synclines, as we can see here, which is also a good representation of the deformation occurred when the salt is involved. Also, we have a lot of noise in the center part of these structures, and in the surface we have anticlines with faulted flanks and inverted beds in both sides, which are also indication of this particular type of deformation. We try to figure out how the geometry of the subsurface would look like, taking into account the maps, the geological maps that we have, and the few seismic that we had. And here in blue are the synclines, and in green are the anticlines. And this is what the geometry looks like. And if we compare that with, this is a map of the North Sea, or part of the North Sea area where there is diapirs and salt involved, we can see some similarities in terms of the geometries of the syncline, and also a little bit as in the geometries of the anticlines. This is in the same scale. So we think that this is a real opportunity here for the industry that should drive the attention to it, because the market, it's really close. Here in number 5, it's the Suezca anticline, and Suezca 1, which was drilled in the 60s, it proved some gas. Therefore, it's good. It's a good place to explore gas, and the opportunities, the kind of place that can be targeted here are numerous. And also, it's important to say that the reservoirs are preserved. The late Cretaceous reservoirs and the Paleogene reservoirs are preserved in this area, and that's really important. Continuing to the north, this is the section number 5. Here we don't have anymore the salt deformation. We have basically a thick skin and some thin skin deformation. And from west to east, we start here with the Arcabuco and the Boyaca Fault, which expose the Jurassic sequence. Here we can see in blue in the map. Then we have in the Stonehenge incline, we have Oligocene sequence. And then number 2 is the southern extension of the Floresta Massif, which is here exposing Paleozoic. And then the Soapaga Fault, which is this big fault here, which puts in contact these early Cretaceous and Paleozoic sequence against Oligocene and Eocene sequence. And from that point towards the east, we have several faults that are verging towards the west, which is in the other sense of these faults. Here is there is this triangular zone, which is important because it's where Corrales and Bolivar are located. So therefore, here we have an interesting play that has been proved. From this point, again, until the Frontal Fold or the border of the actual Cordillera or the Eastern Cordillera, most of the sequence of the Cretaceous sequence has been eroded. Therefore, this is not part of the study. And then from this point to the Frontal Jopal Fold, we have several structures, Copiagua, Cusiana. We don't have to say much about it. We know how big these structures can be. But what we want to highlight here is that besides those structures, there are more reservoirs to be targeted, deeper reservoirs. And we're going to look a little bit more in detail one of these areas. Here, this is a little bit to the south of this section 5. What we want to highlight here is the presence of structures that involve clay basement and the early Cretaceous reservoirs, the Une Formation. This is the map of the Une Formation. Here is Suezca 1, which is the well that tested some gas. Some of these structures have already been drilled, but there are more there to be explored. And here we have a zoom in the area where Corrales and Bolivar are. Here we have the Soapaga Fault, which is this fault running northeast, southwest. And then here we have the Gamesa Fault system, which is running in the same direction, but with the contrary divergence. And below those, or in the footwall of those faults, we have the Corrales Field, which produces from late Cretaceous reservoir, and also it has oil, as Luis mentioned, in the Eocene and Paleogene reservoirs. So it's a multi-target structure that we have here, and there are more opportunities along this area. And also Bolivar well, which also produced from late Cretaceous reservoir, and it is formed by this deformation, by the deformation of the Gamesa Fault. Therefore, the structures in this area, they have great potential. And also to the north, here in the map, we can see these pale colors, which indicates that the Oligocene and the Eocene sequence is preserved. Therefore, below that, in the subsurface, we will have the late Cretaceous reservoirs, which is important because, as I said before, one of the issues of the Eastern Cordillera is that most of the Cretaceous is eroded or has been eroded. Therefore, this is also a potential area with few seismic that it's also a target to be chased. In the foothills, this is a seismic section running in this area. We didn't have access to depth seismic, but anyway, we want to say that the takeaway message here is that there are deeper structures with the reservoirs of late Cretaceous and early Cretaceous, Une and Cachita sandstone. Some fields or some recent wells have proven to these reservoirs working in these areas. Therefore, the foothills are still, they have still potential not only for tertiary reservoirs but also in the Cretaceous reservoirs. And to finish up, the Gibraltar area here to the north, which is also related to the foothills deformation. This is a section that was built based on surface geology and part on seismic. To the west, we have the Santander Massif, and limiting this, the La Bateca fault system. And in number 2, the Aguascalientes fault system, which is the boundary of the actual or the eastern Cordillera. And then from this point towards the east, we have all these structural thrust, the several sheets that were formed, and some of them, a couple of them were the ones that produced in Gibraltar. This is a projection of the well. This is not where the actual well is located. And again, we didn't have access to depth migrated sections, but what we can say from this area, it's really interesting, is that Gibraltar, it tested some of these sheets here, the imbricated sheets that form this flank of the El Descanso syncline, which is running more or less north-south and is located here. But right to the north of it, the Los Deseos syncline is formed, which is another one. And we think that this syncline, it's formed by another fault that separates the sheets that were proven by Gibraltar well. And therefore, to the north, we have more of these structures that are independent and that are play to be pursued. For sure, Ecopetrol, which is the owner of the area, have already this in mind. But what we want to highlight here is that there are more opportunities in the foothills to be explored. The conclusions: the Eastern Cordillera is an inverted basin where different types of structures were developed. There are a great variety of traps, subthrust traps, thin skin, thick skin. There is a play related to salt in the center part. The Guando field, which is a very important field that tests the subthrust, which needs to be assessed in the rest part of the basin. The salt domes, again, in Bogota, which is where we have the market just there, and the triangular zone of the foothold in the footwall of the Soapaga fault, which is an hydrocarbon province where we can have multi-target structures because the late Cretaceous and the tertiary reservoirs are preserved, and the foothills, which represents or where major discoveries have been done, but where late Cretaceous and mid Cretaceous reservoirs should be considered in the following stages of the exploration. So that's all from my side, and I pass over to Cesar.
Thank you, Andres. Now I'm going to present the results of this project about the petroleum system, plate fairway analysis, and jet to find. It was a huge work where we have the opportunity to integrate all the information you see in this presentation from Luis and from Andres. A lot of information, very good information. I'm sure that you will be agree with me that this is one of the best regional studies in the Cordillera Basin, especially because we had the opportunity to integrate the information, and it was integrated for a multidisciplinary group. And first point I'm going to talk is related with the hydrocarbon occurrence and proven plays. Andres was talking about this, but here we have a summary, a brief summary from the 4 fields we have in the basin. I want to mention some points. The first one is that all these proven plays are structural plays. Gibraltar in the northern part, Corrales and Bolivar in the central one, and Guando in the southern part. We have a structural plays. The other point is that the reservoirs correspond to Monserrate Formation, that means is late Cretaceous. We have a Mirador in the northern part in Gibraltar, we have the Eocene sequence there. And in Corrales and Bolivar, we have Upper Cretaceous again, and also we have oil in the Eocene sequence of the Picacho Formation. It is very important because that means until now we have proven the oil in place just in these 2 reservoirs intervals, but you know that we have another kind of options and another options for reservoirs that represent a frontier boundary for the basin. The other point is that this is, in terms of oil in place, this is very small. If we put this amount in the Colombia general picture, but you can see that Guando and Guando Southwest have the most than 60% of the oil in place in the basin. And the other point, the other important point is that Guando was probably the last discovery with this amount of oil in place in Colombia 22 years ago. I believe, I think this is a message for us, for the exploration activity in general, because 22 years is too much time without to find another Guando or a biggest one. We have to change that, and the window to do that is getting smaller and smaller. Then it's very important that from this kind of studies, some companies could have an additional exploration activities in the basin. Another important point for the Cordillera is the presence of the oil seeps. We have a lot of seeps, especially in the axial zone related with the Suapaga fault. We have several studies about these oil seeps. They are active. We have oil there. We have gas in some of these, and it is a proof of the petroleum system active in the area. Also, we have another oil seeps areas in the southern part and in the northern part. But is in general we can see that we have oil seeps. We have shows in different wells. And also we have 4 fields, oil fields, that prove that we are in a frontier area, but with a very good chance to find additional oil in place for the country. About the hydrocarbon potential, in this map is a summary of the points that Luis and Andres were talking about. But we can divide in terms of the exploratory activity. Obviously, this is coming from the geological model, but in terms of exploratory activity, we can divide the basin in these sub areas or sub basins. First one, we have these polygons, this area that correspond to areas where we don't have sedimentary basin. We have igneous or metamorphics. We have the Los Cobardes anticline. We have this complex with the metamorphic and sedimentary rocks in the north. We have the Arcabuco and Floresta Massif, and we have the Quetame Massif in the southern part. In these areas, we are not trying to get this exploration activity. Then we have these areas, the Tablazo subbasin and Cocuy Medina subbasin, that represent a special situation because we lost the Paleogene and Neogene sequence. In this area, we have the Cretaceous, and in this area, from this area, we have most of the information related with the source rocks. That's good in order to know the source rock quality, but obviously here we have problems in terms of the petroleum system and in terms of the exploratory activity because of the uplift. We lose in huge areas. We lose the reservoirs, or they are very close to the surface. Then these areas are important, obviously, but we are not going to concentrate the activity in order to get conventional oils there. The reservoirs will be restricted to this kind of reservoir that Luis was talking about, where we probably are going to have problems with the porosity, with the reservoir quality. Then we have this axial zone, that axial zone that we can divide in the southern part, south to the Nazareth fault, and we have this axial zone when we have Bogota subbasin and we have the Corrales and Bolivar area. Here we have a very good source rock intervals. We know that because the geochemical data, and also we have oil production and we have the oil seeps. And then we have these yellow areas in the central and northern foothills that corresponds with a sequence, a complete sequence where we have the option to have very good source rock. We have in a transitional area between Eastern Cordillera and Llanos foreland. According to that model, we have this distribution of the source rock. It's very impressive, really. It's very good for the basin. We have a very good source rocks that are spent, that today are spent source rock in most of the basin, but that we know that the original hydrocarbon potential was very high. We have all the sequence related to the Cenomanian to Turonian sequence. We have Ondita, Loma Gorda, La Frontera, Chipaque formations. And also we have in the Aptian sequence, we have the Fomeker and Tibasosa sequence, which represent a very, very, very good source rock intervals. In this section, we can see the situation we were talking about here. We had the Cretaceous in the outcrops, and then that's the reason we have information, geochemical information, because from the wells we don't have too much data really. This is a summary of the source rock potential. Here we can see that most of the samples are correspond to the oil window or gas window. We don't have the original hydrocarbon potential in this interpretation because the maturity level Those are spent source rock. And here, when you can see these immature or early mature samples with a very high potential, this corresponds to the Villeta formation around the Alpujarra well. Most of these data are coming from Alpujarra. That means that this is one of the areas where the Cretaceous section is into the oil window. And it is important in order to have a very good timing for the area. Using all the information, the geochemical information, we got this proposal for the kinetics modeling of the source rock. We use this for Fomeke and Chipake formation. We calculate the original potential in terms of TOC and hydrogen index, and we apply the model in order to calculate what kind of fluids we are going to have and how much will be the spelled amount of fluids. You can see here for the Chipake that these values close to maybe 20 million barrels per square kilometer. Those values are similar to the values we can get from La Luna formation, a little bit low than La Luna. But from Fomeke formation, it's really impressive, the amount of oil we can get. Here you can see we can compare here how much oil is coming from Fomeke or their Chronos stratigraphic equivalents, and how much oil is coming from Chipake. Fomeke is really, the Aptian sequence is really probably the best source rock interval in Colombia. Anyway, we have a problem there because of the maturity level, and because of, as a consequence of the boreal history, the generation processes is early, and then we have to be careful about the timing. The next step was to work in the petroleum system modeling, and we start with 1D modeling. We have 5 wells close to the, especially we decide to do this modeling close to the proven place, in trying to understand how this oil is there. And here I'm going to present just this one, the Bolivar Deep, a pseudo well, a well with a pseudo well part in the syncline. And here we have Soapaga, here we have the oil seeps, and according to the boreal depth, we can see that maximum boreal was getting in during the Miocene time, and the maximum maturity level corresponds to a gas window for the Tibasosa source rock interval. And the Chipake formation is very close to the late generation, to the late oil window. It is good for that area because we don't have the hydrocarbon expulsion pools are not let me explain that with this graphic. Here you can see the rate of expulsion, and then we have here the curve for the Tibasosa and this one for Chipake formation. You can see that we have the main expulsion process during the Oligocene in this area for the Aptian source rock interval, and for the Chipake formation from the Turonian, we have that in the Miocene. That means that for this kind of reservoir like Guadalupe and Picacho, we have a good time, a very good timing. And we know that because of the oil fields. When you go to a deeper part of the basin, for example, here in the Bogotá Sud Basin, this is going back. Then in that kind of areas, you are going to have early generation and early expulsion processes. Then the timing will be the geological risk related with timing will be higher on that areas. But this model is good for the axial zone, and also is very similar to the model we can get from the Guando area. That means in that areas we have a very good timing for the hydrocarbon accumulations. Next step was to work in the 3D basin modeling. We use all the maps that were generated by the interpreters, and we developing a migration and charge model for every one of these areas. In the final report, you are going to have the detail of this information. Here we don't have enough time, but anyway, you can see that according to the migration model and the hydrocarbon charge in Gibraltar, for example, in the northern part, you can see north to the Gibraltar, we have option for additional opportunities. You are going to have the volumetrics for these opportunities. In general, they are small, and that will be for every area where we were working, especially because the seismic that the group was using. I'm sure that with a 3D seismic survey here, this will be greater. I'm completely sure that we use the conventional seismic to define these maps. For the Central Park in the Corrales area, again, we have, this is the map for Guadalupe Formation. And here you can see the migration flow paths. You can see accumulation traps that are charged according to the model. And we can define at least 3 playfair waves, where we have option not just for Guadalupe, but also for Picacho Formation, for the Eocene. This is an area where we believe that we have additional options to find oil. Remember that Corrales is an example that how we can change a paradigm in order to go to the geological province where you find oil, but was considered not commercial. In the Suezca area, we have also the same situation. This is the map for Une Formation. You can see that according to the migration model, we have additional traps, some with gas, some with oil. And we have, especially in the Suezca area and in the Manzano 1 area, we have very good options for additional traps and for additional discoveries in the area. In the foothills, we did the same exercise. First for the northern part, close to Cusiana area, and there we can see additional traps. Again, these traps are small, but anyway, we think that this is an area where it's possible to go again. Here we have some wells like Golconda, but according to this interpretation, for example, Golconda is not in a good place in order to find that oil. Then this could be an area where, with a different point of view, the companies could find additional oil. For the Medina area, where we have this huge anticline with oil in Medina 1, according to the map and the migration model, maybe we can understand what is the problem here. We have an anticline, a huge anticline, but anyway, the deep of the anticline is going up to the north, to the northeast. Then that's the reason we have just these closures, the small one. But probably there is an option to see this with a different point of view. Also, we have some opportunities to the west. And also we have a huge areas where the migration pathways are concentrated. And then that could be an additional option in the future to find oil on that areas. Finally, we are going to show the southern part of the basin. Here we have the basement maps, and you can see that according to the migration patterns and the hydrocarbon charge model, we have a lot of accumulation, thinking in the option to have a reservoir like Javi Formation, for example. This is a frontier reservoir. But anyway, according to that model, we have huge amount of traps that could be an option if we have that into the Javi formation, if we have this a very good reservoir, or at least a reservoir. That's the first point for that. Javi formation, we have to study a little bit more about that option. Then we have Caballos, which is the main one of the main reservoirs for the area. We know that it is changing from the phases we have in the upper Magdalena Valley, but anyway, as Luis was showing, we have that unit there. And according to the migration and charge model, again, we have a huge amount of traps that could be charged from the hydrocarbon charge processes we have in the area. We can define at least five place, fairway place, and it's very important to see these. You can see here a train of traps when we have wells, but most of these are not getting the Caballos formation. That's an important point. Here also we have traps, we have migration pathways, and we don't have wells. And also we have this huge area where the migration is concentrated and going to the north. And remember that Andres was talking about the why it's really important to have Guando with the kind of play with the seal against the fault. That means in this area we have an additional opportunity. And finally, we have this for Guadalupe. For Guadalupe, the main problem is that we have that unit in the outcrop in a huge area in the central part. But anyway, we have an option to the north. We can see here some play fairways where this unit is involved on, where we can have again the option that we got in Guando with the Guadalupe sealing to the faults. And then we believe that especially in the northern part, we are still having options for the Guadalupe formation. All these plays, you are going to have that information in the final report. And remember that we are going to have their volumetrics calculation. That volumetrics will be a minimum, I'm sure. I'm completely sure, but because of the seismic problem we had in the interpretation. Finally, about the yet to find, we made a mass balance calculation. We use all these areas we were talking about, and a summary is presented here. Remember that the oil in place discovery is less than 1 billion barrels. And here we have a prospective resource around 6 billion. That means we have a very good chance to find additional oil. And if we use 25% of our recovery factor, we are talking about 1.5 billion barrels, which is very good. Probably that will be concentrated in the axial zone and maybe in the foothills. That's at least that's according to the results we got from the regional integration. That's all I have for you, and if you have any question, we can receive that from the chat.
Thank you very much, Cesar, Luis, and Andres. And I'm going to close with some general comments. Let me. Okay. Okay, as a first conclusion, I think, or we think that the Eastern Cordillera has the place, leads, and prospect ready to evaluate and drill. I think it's very important for the companies to review this report and to see all the information that we show in this presentation. But we think that it's very important to increase the volume and the data available for this kind of studies. And we think that if we have more public information and free information for the industry, we can have a more very interesting results. Like similar that in US and other countries that made public all the information from wells, surface geology, etc., that made public 1 year after being obtained. I think it will be very useful for operators, investors, and the strategies of the ANH and the Geological Survey of Colombia. And when we have more volume and availability of geological and geophysical information, I think we will stimulate additional studies related with groundwater, minerals, infrastructure, and construction. Thank you very much. And I think we can, if you want, Miguel, we can start with questions about the Eastern Cordillera, or do you think we go to the Caguan Basin? Miguel, what do you think?
Kurt, better to continue with the Caguan topic because we are running out of time. Okay.
Okay.
Okay, please.
Okay, I'm going to share again, and okay, the next basin sub-basin will be the Caguan sub-basin. We are going to review the geologic integration, the evaluation of oil system, and prospectivity. The organization is quite the same. Maybe the only difference is that the interpreter is in this group is Catherine Jaime. The other professionals it's quite the same. We have 11 professionals here. As in Cordillera, it's a multidisciplinary, and I want to thank to all of them for a good job and the compromise that you did with this project. Thank you very much. And now, Luis Vergara. Luis, the floor is yours.
Yes, thanks, Kurt. Share the screen. Again, as in the previous talk, I'm going to read the geological framework, chronostratigraphic sections, and gross deposition environment. This work has been done by Gatsby and Peratriz Lopez. I acted as the stratigraphy advisor, but she did the work. As to the geological framework, the geological map of the Geological Survey shows here the basin limits of this is a sub-basin. The Caguan is a sub-basin of the major Putumayo Basin here in the south, which in turn everything is part of the big Putumayo, Marañón, Oriente basins, which are very prolific. Here in Caguan is not that prolific, but still there is one discovery, and there's production of heavy oil there in the Capella oil field, discovered by Emerald Energy. We'll talk about that later, but the limits, as to the limits of the basin, you see the Chiribiquete Mountains, Macarena Mountains over here, the Eastern Cordillera in the northwestern part, particularly the Garzón Massif. And in the south, there is an element called Florencia Paleohigh, which is used to divide one sub-basin from the other. And you can see those structural elements that show up very good in the gravimetry map of Graterol and Vargas, where there's a big intrabasinal high here called Yari Paleohigh. We'll see that. Those are the elements I just mentioned. And basically the pile of sediments, where there is more subsidence in the Caguan Basin is in this area here, where you can see the geometry, basically the geometry of the basin in the prospective area. As to the stratigraphy, we rely on the stratigraphy proposed by Alejandro Mora and others in 1988 for the Putumayo Norte, Putumayo, the northern part of the basin just south of Florencia, based on outcrop studies and age datings. They have proposed nomenclature that we can extend into the Caguan, at least in the south part of it. There is no lower Cretaceous up there. The sedimentation in the Cretaceous starts in the so-called Masaya Formation, which is a Cenomanian-Turonian sand unit. Then you have the phases proper of what they call Villeta informally in other basins. Here it's called Las Iglesias Formation. Then you have that's a Neme sandstone over there. Then you have the Rumillaco, reddish shales. Morelia is also a new term coined by them, sandstone basically. There's a lower and upper Morelia, then the three units of the Pepino, basically conglomeratic, Ortoguasan, Ritable, and complete the section. In the Caguan North, it changes quite a bit, because then you don't have any source rock, and the upper Cretaceous equivalent of Las Iglesias in time is composed of massive sandstones, basically, known as the Macarena group. This is a term also defined by Buccelli and others from the Geological Survey when they mapped the Macarena mountain range. So this is where the reservoir of the Capella field is sitting, is called there informally fractured conglomerate, but again, no source rock there. The source rock is outside the basin, and Cesar Mora will show an interesting model to explain that, where the oil comes from. Morelia, again, there, a potential reservoir. Then you have interformational seals, and the Mirador is also, I understand, it's also all bearing in Capella, and obviously is the reservoir per excellence in the Llanos Basin, and it's topped by the Arayan ultimate top seal over there. So that's so far, well, the basin is the pericrotonic basin, very little deformed, not too much going on there, pretty easy to interpret. So we'll see that in the sections that Andres has prepared. The Chronos stratigraphy, well, it was quite a challenge, because the wells don't have much biostratigraphic information. It's very sparse or scanty or not very reliable. This is one of the two sections that Gatsby then prepared. Longitudinal section from La Turbia up to the Uribe section. Those wells penetrated basement, which is here granitic, and over there is pre-Ordovician. And then the wells of the Capella field, as well as the Uribe well up there, they have penetrated that upper Cretaceous conglomerate, which is prolific, or is productive here in Capella. And it's again, grades into the Macarena group. The so-called basalt sandstones are the attributable to the Morelia Formation, the lower member of Mora and others, which is penetrated in these wells, and it appears to be diachronous, younger towards the north. And there's some wells where there's a gap there. And then we have the Arayan Formation. Well, we have the Mirador Formation, sorry, equivalent to Pepino. And here receives the name in this well of Losada Formation, which is equivalent. Again, a gap here in those wells. And then the Arayan unit, which is the seal, has coal bearings, coal seams, and gastropods. At some points, it's fossiliferous. So that's one of the two sections we've got. Then we've got another one, which is the east-west, and it's basically the same wells in the middle that we showed earlier. We add the wells, the Achote well, which is just next to the mountains to the eastern Cordillera. There you have Morelia on top of the Cretaceous, and there's another gap there identified by palynology. I think Gustavo Sarmiento did this work there. And then again, this other well in Losada, where things become, transgressive by the effect of transgression and become younger. And there's the Guayabero Formation dated Danian to Zelandian, that's in the Paleocene. Right, we'll see the models of that later. This gap is about 10 million years. And at the top, you've got again the topsides of the Arayan Formation. So that's what we can do. By the way, there are no chronostratigraphic sections or any attempt like that known in the literature before. So this is, I think, that's an important stride in the knowledge of this basin, is to trying to put things in the correct position. The gross depositional environment of the upper Cretaceous continuation to Maastrichtian. Here we have, we can see that most of the area was exposed at that time. The Yari Paleohide, of course, the Florencia Paleohide, and most of it was again exposed. This is the area where I pointed out before, where the subsidence is greatest. And here you have the Macarena group again with paleo-environments believed to be fluvio-deltaic, with the fans coming westernly provenance, point sourced. This is the fracture conglomerate here that produces in Capella, and there's another one, presumably easternly sourced in the Losada well. This is the equivalent Las Iglesias, where that crops out here in the mountains, in the San Belén de los Altaquies area. Macarena mountain range here, and then this Uribe well has a section of the Cretaceous that appears to be more neritic, a little bit more marine. Those wells are already in the Llanos Basin, studied by the ICP group mentioned earlier, Regis Harker and others. Here are the sources of the information that you can see here. By the way, we have seismic control of this depositional limit over here and over here as well. So obviously in between this question mark, but these contours actually have seismic support. For the Paleocene late Eocene, then the two basin, Putumayo sub-basin and Caguan sub-basin, then became connected. And these wells will testify to that. That's the depositional limit. And then that's the lower Morelia formation that crops out over there in the mountains in the Putumayo Norte. Most of that are deposits of braided river, braided stream deposits. This is a very intriguing hiatus here, paleohide, which is, you will see that the Mirador is lying directly and conformably over the Cretaceous, and so there's no section here of the Paleocene late Eocene. And you will see that in transect number 3, that is Mesa is going to present later, and that has been mapped using seismic here. The seismic control here to see the onlap of the Morelia, or the reflector that ties to the Morelia in these wells. You see how it onlaps this high. Very interesting feature. And then the Guayabera Formation Again, I think that's defined by Buccelli and others here in outcrops, and it's dated as Paleocene in this area. So conglomeratic and sandstones. In the river well, it's absent. And the Yari Paleohigh. This is basically based on the gravimetry map that I showed in the first slide, as well as now we're in the latest Eocene, which is originally called late Eocene. So this is again a bit conceptual and supported by the gravimetry map. Then we have Pepino and Mirador equivalent with environments sold in the wells as sand flats and over there braided river deposits here and there. The differencia Paleohigh then gets a different configuration here at this stage, and that's controlled by seismic here. So you have this is controlled by seismic. So that's the way it maps out. And then in the north, we have sands that are more attributable to coast and tidal environments. And they're drilled here in the Uribe well. So those are the GDEs. Then let's go very quickly to the petrophysics, again done by Helman Bonilla. I'm going to read his slides. Then we have an example of the Masaya Formation. Very, very sandy. That's in the Uribe well up in the north. If you remember, there are clay zones in this part, but otherwise they're clean sandstones with low gamma rays and volumes of clays, then 10% average or so. High resistivities. This is the resistivity log with possible fluid mobility. Permeability is on the low side, but this well has oil shows here, so that's a good sign, and it's probable potential reservoir. So the fracture conglomerate from the Capella field. This is we have two wells here with we know that they are conglomerates with sandstone interbeds from the mudlog, and so that have quartz fragments, pebbles, and even metamorphic lithics, evidently coming from the Garzón area, from the eastern Cordillera, the Garzón Massif. However, the section doesn't appear to be that sand rich, but this is very difficult to pinpoint where the conglomerates would be the big question here. We don't really know because we don't have special logs. And where are the fractures? We don't have special logs like FMIs or things like that. We have just conventional logs, and that's very difficult to then establish where are the productive zones. We don't have access to the perforations. I don't think so. Here in this well, however, we can tell where are the clean zones. So in this well, you have clean zones there, but appears to be very muddy. And the clean zones might or might not be conglomeratic, or might not be fractured. That's an uncertainty in the evaluation, but the pressure fractures may affect porosity calculations that up to 25% of porosity are possible. Volumes of clay, 12 to 18%, pretty high. But the sandy zones, no, here the volume of clay is low in the sandy zones. In the whole interval, as you can see, appears to be low net to gross. And again, the clay zones obviously have potential because we know they are producing, but we know exactly where from. Morelia Formation, that's the basalt sandstones that I mentioned before, and that's because they are, you will see that in the seismic beautifully, how they transgress the basement. Very high to gross numbers of the Morelia, lower Morelia, clean lithologies, volumes of clays less than 10%, low resistivity values that indicate, well, there's a little deflection between deep and shallow resistivity that doesn't speak actually for the mobilities. Average porosity, nevertheless, is actually adequate. 16% is pretty good, but the permeabilities are not great. Are in the low end. But again, that's also a potential reservoir. And the Mirador Formation in the Capella, I understand it's oil bearing as well. I'm not sure if it produces from Mirador, but we're pretty sure it produces from the conglomerate, fracture conglomerate. Here we have two examples where the upper part is a clean zone with the good reservoir potential. Porosities average 35%, where very little varied. So it's a great porosities, great permeabilities up to 1 darcy. Again, here, 100 millidarcy, there's fluid mobility, and there's a kind of permeability log over there, and porosities around 15% makes it a very attractive target. The Losada Formation, that's a term coined by, I forgot to say, by Pava Silva and Van der Hamen. They're pretty old. They first studied as pioneers the Macarena Mountains. It is equivalent to the Mirador, and you can argue that that they're synonyms. But in this well, it's as denoted, at least by us, as the Losada Formation. Medium net to gross, but the clean sandstones are there with little amount of clay. The high resistivities and deflections support possible fluid mobilities in certain areas. Maximum porosity is above around 15% permeability. Again, not that great, but still the oil should flow. I know of the heavy oil. I forgot to say that the Capella is very heavy, 9.5 API degrees. Who knows if these reservoirs will flow that, but it will flow lighter hydrocarbons. So it's a potential reservoir unit. And finally, to the top seal of the Arayan Formation, well, there are 33,000 feet plus thick. That we don't have complete logs here. That was a problem, but. Despite that, there's some zones, some clean zones there, but most of it is clay. Most of it is very high numbers of volume of clay, up to 80% volume of clay, and again some sandstone intercalations that could have a reservoir potential. But in essence, that's a good ultimate top seal. That's it for me right now. So I'll give the floor again to Andres. Thank you very much.
Thank you very much, Luis. Again, I'm going to present the structural sections and the plays that are in this basin. The interpretation was made by Catherine Jaimes, so thanks to her for excellent job. Four sections were built based on seismic data that is available in the area. We're going to start from south to north. So this is the section number 1. Here, as we can see, there is not much or very few deformation. Basically, the basement is tilted towards the west, and the Mirador Formation is overlapping against the basement, which becomes one of the main plays here to the south. And this continues to be the same kind of setting towards the south in the Putumayo Basin. Moving to the north, this is the second section. Here we start to see some deformation, and we can see reverse faults, high angle basement involved faults, and that creates some structures that have the potential to have hydrocarbons. And here it's important to highlight that we start to have more deformation because we are closer to the eastern Cordillera frontal deformation faults. This is section number 3, which is along the Capella field. Here we can see that the density of faults it's much higher. The same kind of faults, vertical reverse faults that involve basement and that create structures here in some of the younger and in the in the reservoirs that are closer to the basement. Capella, it produces from some basalt conglomerates here, which are not present everywhere. But on top of it, there is the Mirador Formation, which extends to a wider area in the basin. And when we move more to the north, in the area of La Uribe, which is surrounded by the Eastern Cordillera and the La Macarena High, here, what is important to take into account is that the Cretaceous sequence is preserved here, and it shows the connection between the Eastern Cordillera and the Macarena Highs, where this could be another potential petroleum system. Some wells have been drilled there. We can see that there are structures present, same kind of faults we can see there to the north. This is the basement map. We can see that it is shallower to the southeast, and it deepens towards the west. And what is important here to highlight, and the key message here, is that along this strip, along this area, it's where most of the faults will be found, because clearly the Eastern Cordillera Deformation affected mostly this part rather than this area and this area. Therefore, this is the place where exploration should be focused. And there are some patches where there is no a single 2D line. Therefore, there's still space for that. There's also some areas where the density of the surface is very large. Therefore, these kind of faults, they need to be closer line to line or 3D to be properly assessed. And here, in the red dashed line, we have the onlap of the Mirador Formation, which becomes another important play here, which is the stratigraphic play of the Mirador onlapping towards the basement along this area. And this display extends to south to the Putumayo Basin. And these white patches, they are the Morelia basal formation, which is not present everywhere, but it's another reservoir, potential reservoir that is located here in this area, where another set of vertical reverse fault are present. Some seismic examples of how these structures look like. We can see here this huge throw of these faults. This is the projection of the Capella field. We can see here this section, which is not present everywhere, and from this portion is where Capella produced. If we move to the south, here we can see less deformation. The faults are not as dense as in the other part, but here we have to mention that this is, again, that there's some areas here closer to the eastern foothills, which should be assessed with more seismic. But anyway, there are structures here that can be seen easily in the seismic, but that just need more data. And a little bit to the south, again, less deformation, but still there are some structures there. Like, for example, this one, this well is projected along the seismic. So in terms of deformation, this is a basin with very low deformation. The most or the higher one, it's along this area, which is closer to the deformation of the Eastern Cordillera, and it's where we think that the following exploration should be assessed or should be focused. This is the strip of these reverse faults, and the stratigraphic play that can be found here to south, and also here to the south of this area as well. So not much to say more about the structural setting of the basin, and I pass over to Cesar.
Thank you, Andres. Okay, first I want to say sorry because the time a lot of things to summarize. We really appreciate your time. I'm going to take just maybe 10 more minutes. I hope you can stay and to see the final points. About the hydrocarbons occurrence, we have in the basin, we have a field, we have Capella. Andres was talking about this model. We have an structural play with Eocene and Cretaceous reservoirs. We have a heavy oil, and also we have oil seeps. The main area for the oil seeps are related or are close to Florencia, and also we have some oil seeps into the Garzon Massif. That is very important, and we are going to use that as a very important date. The oil in place we found in the basin is 0.3 billion barrels. That's all we have until now. But we have oil shows in different wells in the basin. About the hydrocarbon potential, we don't know we don't have information directly from the source rock. This is very common in some basins in the country. Here you can see that the maturity level of the samples we study are in early generation. We don't have too much hydrogen index, and we don't have too much total organic carbon. And also you can see here in this graph that we have a lot of contamination from the samples. This kind of contamination probably could be migrated oil. That means we were studying more reservoirs than source rocks. It is also common in this kind of sequence when we have this depositional environment for the units. And then we decide to use the regional information from the Upper Magdalena Valley and from the Putumayo area to define and to propose the original hydrocarbon potential for two intervals, the Masaya Formation and the Villeta Formation. And we did the same exercise, the kinetics modeling of that organic phases. And you can see here that from Villeta group, we can get a very good amount of oil. We can get oil and gas, and from Masaya, because of the organic phases, because of the positional environment, you can see here we don't have a very high TOC, and we have a mixture between kerogen type 2 and 3. Then, because of that, we don't have too much oil coming from this unit. From the oil geochemistry, we can say at least 2 points. The first one is this is a gas chromatography from the Capella area, 9 API gravity. We don't have normal paraffins. We don't have saturates here. The oil lose all the saturates because of the biodegradation processes. And also we have a very high values of sulfur content. Probably this is a combination between the source rock, the positional environment, the organic phases, which looks carbonatic, but also it is a concentration of the sulfur because of the biodegradation process. Using the biomarkers, we can see that most of the oils coming from the oil seeps and from the fields are related with a marine carbonate environment for the source rock. How to explain this oil is not easy. We need a hypothetical model, and what kind of model we are using in this work. We are using this paper that was published by Wallaver at 2015, where they are describing a communication between the upper Magdalena Valley and the Caguan and Putumayo area during Cretaceous and Paleocene and Paleogene times. And then for the current situation, we have the uplift of the Garzon Massif, but anyway, we had a communication between these basins, probably during the Oligocene and Miocene. How we know that? Here we have some data that we use in order to use that model. First one is that into the massif, we have Oligocene and Miocene sequence. We know that this sequence were there. Right now, it was uplift, but we know it was deposited there. That's the main point. Then, an additional very important information is that we have Albian to Maastrichtian sequence into the massif, in the northern part, close to Uribe 1, and also in the southern part, close to Florencia, and maybe there is another one here. Here we have another outcrop of Cretaceous. They are small, but they are there. Then we can propose, or we can accept that proposal. And the other point is that here in the upper Magdalena Valley, we have the Cretaceous. In the Candelo well that is located here, we have all that section from the Villeta Formation. And the stratigraphy from Candelo is similar to the stratigraphy in the Putumayo Basin. The Cretaceous from Candelo well looks more like Putumayo than Upper Magdalena Valley. That's the model we use here. Then we apply that model in order to build a 1D model from the Massif, Garzon Massif, and those are the results. We are including 3 different source rock intervals. We are including a tertiary section there because of these outcrops. And according to the results, all these units got the thermal maturity level into the gas window. All these intervals got a very high transformation ratio, close to 100%, and very high expulsion efficiency. And this is the history of this rate of hydrocarbon expulsion. Here we can see that we have an early expulsion here, early between Paleocene and early Eocene, but also probably the main hydrocarbon pools was related with the Miocene deposition, with the Belen deposition, and then for that time we have a huge amount of hydrocarbon migrating in the basin. That could be the hydrocarbon that we found in these kind of reservoirs in the basin. That's the hypothetical model we have to use for that basin right now. And finally, using the same methodology, combining the paleogeographic distribution of the reservoirs, the migration, the hydrocarbon migration model, and the hydrocarbon charge, we define some fair play ways. And most of these are related with the stratigraphic traps. You can see in these maps that we have areas where the migration pathways are concentrated. You can see that here, you can see that here. And then in order to explore that stratigraphic play, this is a very important information because it's important to be there. It's important to be here in this area where we have that concentrations. We have some traps, structural traps. For example, here in the Capella area, we have additional options, but they are small. They are small according to this seismic interpretation. We have the same situation for another areas like like in the Ashote area, and also here to the south part of to the central part of the basin. We have a lot of accumulations, many accumulations, and we have a migration pathways that are concentrated in some areas. Then we can define these playfair waves that are related, most of them are related probably with the small structural traps, and could be very important for stratigraphic traps. This is a basin for stratigraphic trap. Probably Capella is a trap that where we are combining. We have a combination between the structural and the stratigraphic situation, the on-lab. We have a lot of on-lab, as Andres mentioned to you. Then we believe that an important exploration activity in this basin to the future must be concentrated in the definition of that possibilities, the stratigraphic trapping. If we don't get new seismic, 3D seismic, probably will be impossible to find that oil that we believe is there. We did a mass balance exercise for yet to find, but it is very, very hypothetical. We have a huge uncertainty here. Then these results, I won't be worried about these results. We believe this is a basin where we have to go. We have to explore without this concern about these results, because of the uncertainty of the yet to find exercise. We don't know. We don't have right now the area where the oil was generated. Then the hypothetical model has too many points that we can't define at any time. That will be a model forever probably. Then we trying to separate the entire basin in 3 areas: the northern one close to Uribe one, where we have the option for that sequence, the reservoir sequence, the basal reservoirs. We don't have too much exploration there. We need, and we have the option for stratigraphic traps. We have this central area where the Capella is located, and here we have again a lot of unlap from that basal sequence. And the most of the basin, this huge area, correspond an area where we don't have almost anything. We don't have seismic, we don't have too much seismic, we don't have well. Then there we need additional information in order to try to develop a new place. Again, that's all we have. Sorry for the time. Thanks a lot for your patience.
Thank you very much. Again, Cesar and Luis, and I'm going to close with a final comment. Let me share the screen. And okay. Well, the main conclusion, as you see, is that it's clear that Caguan Basin is a frontier basin with oil production, Capella field, and a great opportunity, in my opinion, in our opinion, for visionaries, and the other comments that we did for the Eastern Cordillera. Thank you very much, and Miguel and David, the floor is yours.
Okay, thank you, Cord. Thank you, Cesar, for this, and Luis, Andres, for these amazing presentations that we have had today. I know that we are running out of time. However, I would like to give a couple of minutes if someone from the attendees got any question that maybe we could easily address into this couple of minutes. Otherwise, we invite you, if you got maybe a deep, soft question, to send them through email to the ANH, and we can address that directly to the presenters that we got today. Okay, people is in this very moment leaving the session, so it seems that no one beyond the comment by Luis Diaz directly to the panelists. We don't have any further commentaries or any further questions. So again, it doesn't matter about the time. It's always about the knowledge that we would like to thank Kurt, Andres, Luis, and Cesar for the couple of presentations for Cordillera and afterwards, Caguan. And see you next week with Catatumbo, with Ivan Olaya, and myself. So thank you, everyone. See you in the next opportunity.
Thank you, Daniel.